A lot of students like me when I was in high school, math is really challenging.
I did like math, but there were many times where I didn't see the point.
It's hard to see the application of how you're ever going to use algebra or geometry or statistics in real life.
It becomes a lot more interesting when you can see how the math is going to be used.
My first kind of excitement about math was when I was in a class and doing statistics on data that I actually collected.
When I started to get deeper into the math and the science and to the, sort of the higher levels, that's really when it got interesting.
One of the areas that's very important when you're looking at human performance research is to have an understanding of statistics.
There's certain statistical procedures that you can use depending on the number of people that you run through the experiment that will give you a confidence interval of is this statistically significant or not.
And to understand how to set up experiments correctly, how to choose the right data.
Once we've collected data in a specific scenario, how do we take that data and turn it into something meaningful?
You know, taking two things that are totally unrelated and finding the connection.
Univariate and multivariate or bivariate data is basically the difference between having one thing that varies and more than one thing that varies. I could look at the relationship between just that one singular line, or I could look at the relationship between many things. So how does an individual interact with system A, system B, system C? And then I could do different univariate or multivariate analyses on those different things that are varying. One of the first projects I can remember is our instructor asked us to go out and collect data on foot length and height, and then just do a basic correlation of how those things are related. So then we collected that data with just a measuring tape, and then went back and took that data and did a basic correlation. And then from that we could see that, yes, there's a real relationship between your foot length and how tall you were. If you do waist to arm, you might find no relationship. Might not find a relationship on things like thigh to arm length, but it's kind of cool to see how those different things are related or not related, and then you're using statistics in a real-world scenario to kind of uncover those problems.
Recently, I was a judge at a regional science fair, and one of the projects that caught my eye was a fifth grader who did a very simple experiment about texting and juggling. And what she did was had people text and juggled and counted how many drop balls that they had, how long were they able to keep going, and so on, and clearly showed that you cannot divide your attention between the two tasks. Now you might think, well, okay, but what happens when you're driving? The same divided attention situation occurs when you're texting and driving.
Basically, within human factor psychology or human performance psychology, I really focus on performance under stress. So when Air Force pilots are flying really high up in the sky, about 50,000 feet, it's typical that they lose oxygen to their brain because they're flying super fast. So that's one stressor we look at. I also look at motion sickness as a stressor. I look at high workload as a stressor. So when you're working really really hard and get overwhelmed by the task that you're working on. I study fatigue, so sleep deprivation as a stressor. So stress can be conceptualized as a lot of different environmental stressors and operational stressors, and I really look at performance in each of those specific domains.
Sometimes we think we're not good at math or science because it hasn't excited us yet. But once you realize I really love doing this, you want to do better, and it becomes easier for you.
In my graduate work, when I started actually using it towards something that I was interested in, then it becomes interesting.
Start with real-world examples. Why is this important?
Understanding that the real-world application is really where it's at, and that's what gets you really excited until the point where you realize, you know what, this isn't really that hard if I can understand how it really is going to help me, figure something out.